As Jason said, I am Alastair, and I am a software engineer at Canonical, and I work on the Juju team. So today, I'm going to be showing you how of open source with Juju. So for the agenda, I'm going to start with what is hard about open source today, then what is Juju, and how does it solve these problems, and then how can you use Juju to power your applications? So, what is hard about using open source software today? And by the way, I'm talking specifically in the environment of cloud deployment and running things in production. So, software is more open source than ever. 20 years ago, if you wanted to get some open source software to use with your application as like a backing service, or like if you needed, a database or a cache or something, then the default solution would be proprietary software. You would generally go to a company that provided that service. Open source was seen as a kind of like fringe and hobby project kind of thing. But now, it is everywhere. There is a lot of open source out there. More than we can imagine, right? If you want some particular service, like a database or whatever, you have tens of really high quality options. So things that are well crafted, well maintained, well documented, and available for free. But I'm going to ask a different question. Is software more open than ever? Open source is not just a thing where you put your code on the internet. Open source is a philosophy. It's not just about making your software available for everyone. It's about making your software accessible for everybody. So if I publish a load of source code that's obfuscated and confusing and takes months of training to even operate, is that really embodying what it means to be open source? In my opinion, not really. And today, production environments are more complex than ever. You're not just running on a machine. You've got your machine, which is in a cloud, which maybe has some VMs on it, which maybe has Kubernetes on top of that. You've got all these layers going on. So there's not just the actual physical infrastructure, but the virtual infrastructure as well on top of it. And deployment environments end up so complex because of it. So when you're deploying your software on your cloud and operating it, you have lots of different sort of phases to consider. You have like the deployment, which often requires the specialist knowledge of the application and of the cloud. So not just your application, but all the applications that you need to back that application, like the cache and the database and so on. There's also the integrations, so integrating your application with other applications that it needs, updates when there are updates for any of the different services that you're using, your application as well, and then scaling, high availability, all of these things that require specialist knowledge of the application. Then portability as well, right? So if you're running on a particular cloud and they hike their prices or they stop supporting like a feature that you really need, then it'd be really useful if you can move your deployment over to a different cloud, but that often requires almost rewriting your entire deployment script and all of this, whatever, Helm charts, Ansible playbooks you've got. So on that point, isn't this problem already solved? Kind of, but not really. So the deployment part of it is really well solved. Things like, Helm plus Kubernetes and Ansible and Terraform make it really easy to specify your deployment really well. But the maintenance phase, the phase that comes after that in operations, where you're trying to keep your software going, keeping it up to date, scaling it, doing all these integrations, and doing these things dynamically as well, is not quite so easy. So what if you have your big deployment, you've got your database and you've got your observability or whatever, but you want to not just observe your own app, but also have your Prometheus scrape from your database, from your Postgres. You can do that, but you have to figure out yourself how those two components interact. You've got to go into the config files, you've got to have a lot of knowledge of those two pieces. Same if you want to scale your database, right? That's a different thing for every database. You've got to know how to do it for that database. If you want to make backups across all your apps, you've also got to figure out how each individual app does backups, and they can all be different, right? And then even if you do figure all this stuff out, you've got the whole new set of configuration files that you've created to do this, and scripts or whatever, which now need maintaining if you want to keep that going as you change your deployment. So you have this extra layer of complexity. So the issue here, right? The software itself is open source, but the operations, not so much. And this is the issue that the software I work on, Juju, endeavors to solve. So yeah, what is Juju and how does it solve these problems? So the idea behind Juju is codifying operational knowledge. Yes? Juju, well, the meaning of the name is black magic, right? And that is why Juju is called Juju, because this is black magic for the cloud, right? You're getting a lot of really cool things without necessarily knowing the details of it all, right? So yeah, I'll continue there. So Juju codifies operational knowledge. So the idea is that all that figuring out of things that you had to do to, to deploy, to scale, to whatever, that knowledge can be codified. It can be turned into Python code in the case of Juju, and that is something we call a charm. So charms are Python code that operate applications. So the charms themselves are things written by people who are experts in the application, and the charms define how you do these common operations. So things like scaling, things like deploying, things like integrating with other applications. So the authors of the charm have got this opinionated way of doing these things. All you need to do is tell Juju to deploy the application or integrate Postgres with Prometheus, and it will do it. It will talk to the charms will implement the operations on the application, change the config files, whatever, and make that happen for you. This actually ends up making a lot of these cloud operations I was talking about earlier really simple, right? You can actually do it in one command, which kind of seems like something that is almost impossible today. But it exists, right? So, yeah, and just to clarify, so charms are not something that's just like run once, like a sort of script. They live alongside the application in the cloud. So they're sitting next to it for its whole life cycle and managing it. And Juju is managing the charms. So where can you get these charms? There's a website called charmhub.io, and it has a huge range of charms that already exist. These are maintained by Canonical and others, and they are all open source and free. And so is everything that I'm talking about today. So you can deploy these charms with Juju and integrate them with each other, and you can deploy them on a huge range of substrates, right? So Juju integrates with public clouds, with private clouds as well, like OpenStack. It also works on Kubernetes. So, yeah, question? It used to work on Windows. Nobody used it, so we scrapped that. Yeah, no, that was too much pain to maintain and not enough gain. Yeah, you can use, I believe, I haven't done it myself, but I believe you can use it with microcloud. Yes, so just to visualize that setup, so you have the Juju CLI, which is on your laptop or whatever. You have your cloud, and in that cloud is a Juju controller. And that controller is operating the charms, which are sitting next to your software. And these dotted lines around them are models. So this is a sort of concept specific to Juju that, well, I say specific to Juju, it's similar to Kubernetes namespaces, but Juju had the idea first. These are, models which contain a collection of applications. Question, yeah? in a way, they're... Oh yeah, sorry, I'll repeat the question, yeah. So the question was, can the charms be considered an extension of the application? In a way, yes, right? So in the ideal world where Juju is everywhere and everyone is using it, then it would probably be the people who write the application who also write the charm, because the charm is effectively how to operate the application, right? Obviously, we're not in that world today, and so the charms are, they exist on Charm Hub, and they're not written, some are written by the people who make the applications, but most of them are generally not. But yeah, they are effectively a continuation of the code of the application, right? They operate the application. Yeah, so the next section is how can you use Juju to power your application, right? So there's all these pieces of charmed software that exist, but you have your specific, I don't know, Go application or whatever, and it would be really cool if you could deploy that with a charm and put that on the cloud. So that is what I'm going to show you today. There's a cool new initiative that has come out of Canonical recently that is called the 12-factor charming process, and is effectively an on-Rails way to turn your Go app or Django app or Flask app or FastAPI app, along with a few other, well, I think they're working on a few other platforms, into a charm. Well, I say into a charm, in creating a charm to run that app, right? So hands up here, who knows what a 12-factor app is? Okay, cool, a few, but I will explain it, so don't worry. A 12-factor app is an application that fulfills all of these, but we are only concerned with the ones that matter for operations. So these in particular are having all the dependencies explicitly declared and isolated. So that is to say, we don't want an dependency that's just sort of built into your application in a way that is really, just part of the application. You want to do it sort of on the separately. You want to explicitly declare them so that they can be easily installed and easily managed. Next is config. So config should be declared through the environment, meaning environmental variables, as opposed to a YAML file or whatever. This is just a standard way to do config, right? Next one, backing services should be treated as attached resources. That is, you shouldn't care if your backing service is swapped out. Your app should be resilient to that, and it should be treated as a separate thing, not just part of your single blob. For the next one is processes. So your app should execute as a stateless process. That doesn't mean you can't have state. That means that if you need state, you should have it in something that runs state, like a cache or a database. You shouldn't be relying on the memory or the file system, because those things can fail and you can be redeployed. And the final one is exporting your services via port bindings. So that means not just writing your output to a random file, but exposing your service via a port. It could be, this is just the an opinionated way that makes it really easy to communicate with the app and for other apps to communicate with it. So what are we going to build today? I'm going to demonstrate today building a Go app and charming that, and then running it, and then deploying it. So we're going to start with a Go app. We're then going to put it in a container. Then we're going to create a charm for it. And then once we've done that, we're going to bootstrap Juju, which is bootstrapping Juju, creating a controller for Juju on a micro-K8s cloud. So if you haven't heard of micro-K8s, it's a really simple, well, not simple, but a basic Kubernetes distribution that you can get running on your laptop. It's really useful for testing and just having something that you can locally deploy on. And that is what we're going to use today. As I said earlier, Juju works with any Kubernetes distribution that's CNCF compliant, and micro-K8s is one of those. So we have microcates. We're going to deploy bootstrap our Juju controller on microcates, and then we are going to deploy our app on that. We are then going to deploy Postgres and integrate that with our app, and then an observability stack and integrate that with our app as well. Meaning that we've gone from a Go app standing alone to a fully production-ready Go app in the cloud with a backing database, with an observability stack as well there that can be scaled, can be, is resilient, is usable in production, which, in my opinion, is a really cool thing, right? So, first, we're going to start by creating the Go application and the OCI image. So, hopefully these videos work. I've been informed the Wi-Fi is okay, but not great. Okay, so we have our Go application here. It's really basic. So this is literally just a hello world handler that you send a GET request to it, and it will return hello world. And I'll just unpause, and we will build that app and then test it out. So split the screen and curl. So hello world, as you might expect. And the next step is to pack this app into an OCI container. So to do that, we're going to use a tool called Rockcraft, which is similar to Docker, in that Docker also creates OCI containers, but Rockcraft uses a static YAML file to do that, rather than having a sort of procedural language like Docker does. And it also happens to have a very convenient extension, which makes it really easy to create a OCI image for a Go application, which is what we're using there with the profile Go framework. So this is the rockcraft.yaml, so the YAML file that shows you what's in the rock. And as you can see, the extension Go framework is there. So we're then going to do rockcraft pack, which will create the actual OCI image. And I've sped this up because it takes a while, as you can see. Sorry? The base image is Ubuntu. I think it was, in the rockcraft YAML, Ubuntu 2404. So we've got our rock packed, and you can see it's there in the directory. We're now going to upload that rock to our microcates image repository. So microcates is running on my laptop here in the background, and there is a image repository at port 32,000. So this kind of obscure looking command is, so rockcraft is a snap, and it comes with Scopio, and that dot syntax is just saying use Scopio in rockcraft. And the insecure policy stuff there at the top is because it's not TLS certificate, not TLS encrypted even. So we're just uploading the rock, because it's all local, that is, uploading the rock to this local microcates image repository, which will allow us to use it later on. So we do that, and that's it. So we have now created our OCI image for our Go application. The next step is to create our charm. So to do that, when the video loads, we will make a new directory for the charm, and then do charmcraft in it. So charmcraft is another tool similar to rockcraft, but for charms, right? So you create charms with this, and again, charmcraft has a really convenient framework called profile called Go framework that is used. Hang on, I'll go back a sec. Yeah, a really convenient profile called Go framework, which will automatically create a charm for a Go application. And that's what we'll use here. We'll initialize the charm, have a look at the charmcraft.yaml. So this has the information about the charm. This is a new charm that we're creating. So the rock is the OCI image, and we're now creating a separate to that, a charm. So the charm is the thing that's going to manage our ROC, well, our OCI image, i.e. our Go application at the end of the day. And this framework that it's initialized with comes with a load of code to automatically integrate any Go application with other services. For example, as you can see commented out here, Postgres, MongoDB, Redis, that kind of thing. And so basically this charm makes it really easy to attach these things to your application. So we will pack that charm. Oh, sorry, first we'll download all the libraries that it needs, and then we will pack the charm. And again, this can be a bit slow, but it's its own snap, yeah. Yeah, I have kind of skipped all the install snaps phase of all of this. But at the end, I'm going to share the link, by the way, to a tutorial that does have all of that. So it's, yeah, don't worry about taking, notes from the slides or whatever. Cool. So that was surprisingly simple, right? But we have now got a charm for our application. So the next thing we're going to do is bootstrap Juju on the Microcates cloud. Bootstrapping meaning just creating that initial controller and then setting up the models that we need, or the model that we need to deploy our application in. So we will start once the video loads. I was warned the Wi-Fi wasn't great here. I've plugged in an Ethernet cable, but I don't know if it's doing anything. That's too far. Let's try again. Exactly. Yeah, there we go, yay. So, Juju Bootstrap Microcates Dev. Oh, dear, pressed the wrong button. Now I've got to hope it loads again. All that progress for nothing. Okay, there we go. So this command will find the Microcates snap that is installed on our system already and contact it behind the scenes and create the necessary pods that are needed to put the controller on there. This will just happen fully automatically, so we bootstrapped, and now I'm just going to run Microcates get pods to see the pods that have been deployed. So as you can see, we have a controller and model operator, which is part of the Juju deployment. We're now going to add our model called Go Hello World. And there, as you can see, we've done Juju status to see what's in the model, and it's currently empty, as you might expect. We haven't deployed anything to that model yet. Cool, so we have our Juju controller in the cloud. The next step is to deploy our application. So let's give that a go. So we have the model, right, that we just added, so we're going to deploy our application into that. And as you may have noticed, our application currently doesn't use a database or observability stuff at all. So we're going to, later on in the next slide, after this one, rewrite the application to add those things so that we can actually demonstrate that. But for the moment, I'm just showing how you can get a charm deployed onto your cloud with Juju. Admittedly, with this particular application, that's entirely pointless, but we're doing it just for demonstration purposes. Any questions whilst we're waiting? With load balancing as in, well, I mean, I've only got one instance of the application, right? So I'm... Yeah. Yeah, I believe so, because we're using Kubernetes, right? So what you can do, you can tell Juju to scale up your application, and it will do that. It will load balance it automatically. Okay, so what we've got here, I've split my terminal, and on the top half, we're watching Juju status, so that is just showing the contents of the model and keeping it updated. And then on the bottom, we are going to deploy the application. So we specify the charm, and then we specify the image as a resource for the charm. So we're pointing it to that microcates repo. Oh, yeah. That's true. Yeah, I've admittedly called everything Hello World, which is quite confusing. But so what we've got there is a model called Hello World model, which is currently empty because we haven't run this deploy command yet. We've got a charm, so that's also again called Hello World, but that is the charm which doesn't actually contain the OCI image, but that charm is the software that is managing that OCI image. We haven't actually had to write any Python code, right? Because the extension happens to take care of it all for us. You can obviously write Python code to extend that extension and to make your charm do more stuff than it does by default. But yeah, that is the charm. And then we have in the image registry, that is the Rockcraft image that we uploaded. So that local host with... Exactly. Yeah, yeah. So we're going to see when I... Yeah. Hopefully it'll be clearer from the status at the top once it starts actually deploying. But yeah, we have the application there. And then, so we've got two rows there that might be confusing, right? App and unit. So the application is the whole sort of the charm, right? That is what we specified here. Units are instances of it. So if you did scale it up, as you were saying, you would have 3 units, but you still have one application. So right now, and for this whole demo, we're only going to have 1 unit for everything we're doing, everything we're deploying, because we're not going to. I'm not included any scaling up in this demo. But yeah, that is a sort of difference there, right? Cool. So we've deployed it, and we're just going to ping it to prove that it works. Cool. So the next step is to rewrite the application to use Postgres and also observability stuff at the same time, and then I'm going to show you deploying it with Postgres. So to rewrite the application, we're going to have to wait for the video to load again. Perfect. So we're going to go into the main.go, delete what was there, and then, okay, so at the top you can see we have defined a new Prometheus metric called db queries total. We're going to use that to count the number of db queries just as an example metric to use. And then we have rewritten our hello world handler. So this starts by grabbing from the environment the variable Postgres db connect string, which is a variable filled by the charm when it integrates with Postgres. So this will happen automatically in the background. And as the app, we can assume that we have that available to us. And the charm takes care of that, right? So we grab that, then we connect to the database, and we insert into a table called visitors the details about the person who has just called that endpoint. And then we increment the db total, the db query total metric. And that's the first handler. We've also added a second handler called visitors, and this will return the number of people who have so far visited called the first handler, basically, by counting the number of rows in the visitors table. So at the bottom, we just register those handlers, and as you can see, we also register the /metrics endpoint, and that is the endpoint that Prometheus will automatically look for on your application to get metrics about it. And that's all taken care of by the Prometheus Golang library. Cool, so we can build that, and then we can try running it. Though, as you may have guessed, it won't actually work because we don't have a database currently connected. We're just running the pure Go application. It's going to look for that environmental variable, and it's not there. So we get an error. So what we need to do is pack that as a rock, go through all the same processes as we did before, and, oh, okay, hang on. There's a step I forgot here. So, right, we've just opened a file called migrate.sh. And in this file, we are putting a statement to create a table in a database if there is not already one. So this is a little shell script that is included with the charm and will be run on the integration between Postgres and the charm. So every time the charm connects to a our application's charm connects to a Postgres charm, it will run this script to create the table on the Postgres instance. So that means that if the Postgres drops and comes back, whatever, then it'll be reset because we haven't set up any state for that Postgres, but we will at least have our table. And the name of this, migrate.sh, is in the charm. It looks out for that for a script with that particular name, and it will do exactly that. It will run it when the integration happens. And I've just pressed the wrong button, so I'm going to have to replay the video, or try to. Okay, let's skip through. Sweet. Okay, where are we now? So, right, we've got that migrate.sh script. We've made it executable here. And now we're going to go into the rockcraft.yaml, and we're going to bump the version so that we can differentiate it from the first one. And then we are also going to add some parts to it, so here, when it formats it correctly, we have the Postgres client, which is the program we were calling from that bash script, the migrate.sh, and then also the bash service itself, because it is not automatically included in this OCI image. So we have to add it, because this is a really minimal image, by the way. I think, I don't know if I think I said earlier it runs on Ubuntu, right? But this, I believe I might have been incorrect, because I think this particular one doesn't even include an OS. It's super basic. It literally is just the Go application running with a systemd equivalent called Pebble. So we will now pack that rock. So this is one of these things that Canonical has been trying to do, is to create these unified, they're as similar as they can reasonably be. They're not similar to the point of meaning it stops working, or you've got features that shouldn't be there. But the idea is these things are you can easily, if you know how to create a snap already, by the way, snaps as well use a very similar, language and syntax. So if you know how to create a snap, it should be fairly easy to transfer to creating a charm and also to a rock. So let's continue. So we have our rock we've just packed. We're going to do the same thing where we upload that rock to the local microcates image repository, and then clear the terminal, and then we're going to go in and update our charm. So we only need to do a very simple update here, which is to add that our charm requires a connection from a Postgres charm, or requires an integration specifically from Postgres charm. So when we put this in, the charm will know, because it says optional false, that until it gets that Postgres connection, integration, then it's not actually ready to go, and it will mark itself as blocked because of that. So we'll do charmcraft pack and get the charm. Okay, so now we should have everything we need. So we're going to watch Juju status on the top, and then on the bottom, we're going to do Juju refresh. And Juju refresh is similar to Juju deploy, except that we've already got an app, so we're refreshing it instead of deploying it. So we specify the path to the new charm, and we specify the new resource that we're using with it. So that's version 2 of the image. I haven't bothered versioning the charms in this, which hopefully is not too confusing. But so we're now using the new charm, and we are now going to deploy Postgres. And in a second, we should see that come up on the top. And as you can see, the Go Hello World charm there is marked as blocked, because it is currently waiting for the Postgres integration. So it's going to take a while for Postgres to actually come up, but once it does, those two should settle down, and they'll be both happy and active. And so these charms will automatically retry all the failed, what they're called sort of hooks, which are like events. So if it tries to, connect to the Postgres client, even if it's integrated and the Postgres is not actually up yet, it'll, come back with an error, but it'll just keep retrying every, minute or however long is specified. Yeah. Say again? Yeah, so the question is, are those tunable, the retry parameters? I'm not 100% sure, now I think about it. I think you can in some cases, but it's not, it's mostly managed by Juju itself, rather than the charm. Yeah. You can, get like Juju debug logs and things like that. If you can also get sort of proper observability on the controller itself. So, after this, I'm going to show you deploying the observability stack. One of the things which you can do with that is integrate it with your Juju controller and then get a load of cool observability statistics on, your controller, which is also deployed in the cloud. Cool, so we have our app and we have Postgres and they're integrated. So Hello World works again. Sweet. Okay, so before I skip it, so we've got Postgres, we've got our app in the cloud, we've got everything else except for the observability stack. So that is what we are going to deploy next. So when that loads. Yes, nice. Okay, so same setup. As you might have noticed, I've zoomed out a bit because the observability stack that we're deploying has a lot of charms in it. So this is, it's called COS Lite, and COS Lite stands for Canonical Observability Stack Lite. And it includes a load of useful things, so Grafana, Prometheus, Loki, Alert Manager, and a few other sort of backing applications for those. And it is, rather than just being an individual charm that we're deploying there, it's a bundle, which means it's a collection of charms. And so we've deployed them, and then here we're integrating them. And again, the charm that we created has those integrations automatically set up. So again, we've had to do no extra effort to have this free integration with Grafana, Prometheus, and Loki, which is really cool. So now we're going to wait for all of that to deploy and settle down, which again takes a while. And all of these applications are, retrying failed hooks, things that have that are failing because they're just waiting for something else to come up, right? Cool. So we have deployed everything. We're now just going to send some requests, generate some metrics, so that our app is actually doing something. And yeah, as you can see there, our visitors endpoint is working. We've had 9 visitors to our app. So, right, we've done that. And now one of the charms here called catalog makes it easy to find the endpoints that we're running our actual observability software on. So here I've just opened up Prometheus, and as you can see, that DB queries total, so that was the metric that we defined in our Go application, has been automatically scraped by Prometheus. So the charms, when they integrated, Prometheus was told about the IP of the Go application, and it has gone there, looked for the metrics endpoint, found it, and then put this in the database. And yeah, so we've got our statistics there. And as you can see, there's 2 labels, one for the visitors endpoint and one for the normal endpoint. And yeah, they have a load of extra labels that include information about the model and the charm and things like that. So yeah, that's pretty cool. So we've also got Grafana is there. So we can have a look at that. What we're doing here is running a action on the Grafana charm. So an action is something that the charm itself defines as something we can basically ask it. So here we're doing get admin password. So we run that action on the charm, and the charm returns to us the admin password that we need to access the Grafana dashboard. I'm not entirely sure how the actual charm has implemented that, magic, right? Yeah, so there's, people who have, the charms are very, heavily developed, right? And there's a lot of code, so there's a huge amount of complexity. I don't know how complex getting the admin password is, probably not very, but yeah, the charm will be doing whatever it needs to do to get the admin password, and we've got it abstracted to the level that all we have to do is ask the charm what the admin password is. Cool, so open up Grafana, copy in that admin password, and log in. And then let's go to the dashboards. We will be able to, from this Grafana, get access to all the metrics from Prometheus that are in the database. But it so happens that the Go charm that we developed, the one that we've just created that we didn't have to add much to, that automatically scrapes a load of really useful information about the Go application, like the garbage collection times and things like that, that could be very useful. You can also add extra dashboards on here and add extra metrics if you want. But yeah, this literally comes by default, right? So we have, without very minimal effort, we have got full observability on that Go application. You can also do things like tracing and a lot more. Yeah, question? So the integration automatically, so our charm was, which we created with that Go profile, automatically does that collection of data. And when we integrate it, Prometheus is then also told about that, and it can get that information as well. So there's a lot of stuff kind of happening behind the scenes here, right? There's a lot of magic, a lot of Juju happening. But yeah, it makes it really smooth getting all this information. And yeah, so that is all I have to show today. There is a lot more I could show, but I only have so much time. So this is a link to a tutorial that covers some of what I talked about today, not all of it. This is all quite new work, this Go application charming, and also, yeah, the Flask and FastAPI and Django charming. And so there's going to be more about it in the future. Right now, this is a tutorial that just gets you sort of started. And yeah, as I said earlier, it includes all the stuff I've had in the background, like the installing the snaps and setting up the environment and all of that. Yeah, so does anyone have any further questions? Yes, Mike.
That way everyone can hear. Wow, that's so loud. That way everyone can hear questions at the end. Here you go.
Thank you. So you showed 3 commands to integrate the observability stack,
yep.
But you didn't do the same for Postgres.
I did. It was probably just, okay. I think I didn't mention it. I forgot to mention it at the time. I did do that. So yeah, you sort of separately deploy and then run a command to integrate. And something I probably should have done when I recorded all these demos is in the Juju status, you can add a -- relations flag, which will show you all the integrations that you've got. So there I was just running the command and it just disappeared off into the ether, right? But you can also just see which integrations you currently have for visibility, right? Another question?
I just want to make sure I understand the value prop of Juju here. So I want to say a couple of things, and if anything here isn't right, correct me.
Sure.
So it seems like when it comes to Docker versus Juju, let's put those two together. Both of them are going to be working on OCI containers, so there's not really an advantage there. It's the same thing. Both of them also seem to be managing network configurations, like Docker has Docker networks, and it seems like we're doing some assumed connections here and some configuration that's happening through charms and other things that pre-exist. So we both have containers, we both have networks. You were also managing relationships between things, so you had your application and then Postgres. But Docker with Docker Compose also has stacks, right? So at that point, we have similar functionality. As I see it, what Juju is giving us seems to be 2 things based on the presentation, and this is where I want you to correct me. Mm-hmm. One of which is a control plane for us to interact with the application without having to have custom scripts made. Something like when a charm is made, we can then interact with it using the Juju CLI without having to then worry about what machine is that going to, how do we communicate with the individual nodes, how does that information get to and
Right.
from.
Yeah.
And then the other bit seems to be that some of the sysadmin side of it with charms gets taken care of for us, or at least we have placeholders to put in our own action without then having to do the IPC, the inter-process communication between the nodes, or by building our applications to be aware of it. We can abstract the awareness of where they're running by charms. Are those two statements correct?
I would say generally yes, in that the charms are that further level of abstraction over what you have in things like Docker Compose. And the idea is that you can do away with things like configuration files and having to worry manually about all these scripts, and that is taken care of you by the people who write the charms. And the charms have a lot of scope to, the charm authors, they can write the charm to do a huge amount of stuff, right? You can have a really basic charm, or you can have a really complicated, powerful charm. And that is sort of capturing that like complexity, right, that was previously in your scripts on your deployment, whatever. Yeah, I think that what you said, to my knowledge, sort of does capture, yeah, the spirit of Juju.
Sweet. So the follow-up and then the end of the question line would be then, going back to the beginning of your presentation, you were talking about open source being a difference between having code versus the documentation and the infrastructure and ability to run it. It seems like the value prop of Juju is, in addition to having the code, you're abstracting the layer of interoperability such that while AWS can do scaling and Postgres stuff, or some other cloud provider in their own implementation of whatever technology like DigitalOcean or Linode, whatever they're doing, they can do what Juju's doing, it seems. But because Juju is genuinely a platform-independent thing, you are avoiding platform lock-in while still having some of the niceties across these platforms.
Right. So, yeah, to that point, like AWS or whatever has its own implementation of scaling. Juju will generally be using that implementation of scaling, right? It's, or at least, I mean, it can depend how the charm's written or whatever. No, maybe that's not quite true. But yeah, the charms themselves, the operations code, are independent of the clouds. So the Juju controller is what sort of has that layer in between the two that will implement these operations on the different clouds. And currently we have, integration with a load of different clouds, and we're sort of keeping those integrations up to date so that we can get as many of the good things that are coming out of the clouds as we can to work with the charms. But yeah, the idea is the charms themselves shouldn't depend on the cloud implementations. I don't know if I've really sort of addressed the question there, but yeah.
It sounds like what you're saying is that the Juju is in itself an abstraction that allows whoever the user is to implement whatever logic they need in a programmatic way, regardless of the platform underneath it.
Yeah. Juju is like a further level of abstraction, right, above what we generally currently have. I guess that is, yeah, a way to put it.
Gotcha. Thank you.
Nice. Any further questions?
Each charm has its own revision. Can we pin certain charms to certain revisions?
Yeah, you absolutely can. Yeah. Yes. Yeah, if there's no more questions, then yeah, thank you very much.
Round of applause. Oh.
Sorry. Another question.
Yeah, so just the follow-up for here, you have the tutorial, your LinkedIn, and the Juju homepage. If someone wanted to become involved with the open work around Juju, where would you direct them for their, not just like the page that describes it, but
Yes.
your Juju Hello World?
There is, on Charm Hub, which I mentioned earlier, there's a discourse forum where you can ask questions and get involved. We also have a matrix chat. I should probably have linked to them here, to be honest, but yeah, there is a whole community out there. Yeah, and you're very welcome to get involved.
Sweet, thanks.
Nice.